Class 7. Welcome to the chemistry class once again. So today what we are going to do, we are going to learn a bit more about the chemical reactions which will be related to the chapter number 2. So we are going to learn some of the or discuss some of the activities which are related to chemical changes. Okay. So first we will start with the addition of zinc granules and dilute hydrochloric acid. Now HCl stands for what? HCl stands for hydrochloric acids. Alright. Now what happens here in the setup, you can see the picture. First what we require a test tube. Okay, so this is a test tube. Alright, now after taking the test tube, it should be dry and clean without any other chemicals stick to it. After that, we are doing what? We are pouring some of the dilute hydrochloric acid. Now note this term dilute. What this dilute stands for? When the concentrated or raw hydrochloric acid is added with water, it becomes dilute. That means it becomes less raw or less concentrated. Okay. So, in our experiment, we are going to take dilute hydrochloric acid. Okay. So, we are pouring some of the dilute hydrochloric acid. Here, these blue marks are denoting the dilute hydrochloric acid. After we are done with the pouring of dilute hydrochloric acid, we are pouring some of the zinc granules. Okay. So, zinc granules are some of the elements, or these are the metals, chemicals rather we should say. These are poured inside the dilute hydrochloric acid. Now, what we are going to see that? Then we are going to see that the evolution of the bubbles. See, it started. Okay. And the test tube, eventually this entire setup of the test tube becomes hot. And then for another activity or another thing, to prove another thing, we need a matchstick. So this is a matchstick we have taken. Okay. So what are the changes we are going to see? While observing, we will see evolution of bubbles. Okay. Now here, evolution of bubbles will denote what? It will denote the evolution of gas. Okay. Because only gas evolves, and when it is inside the liquid, that is the dilute hydrochloric acid is the liquid medium, it will evolve as the bubbles. Alright. Then the test tube will turn eventually hot. Now, why this test tube turn eventually hot? Because of the release of energy, and this will prove what? This will prove that it's an exothermic change, right? Because we have already studied that in exothermic changes, the heat evolves. The heat has been evolving. That's why the entire setup has become hot, and we cannot hold it by our hand. That's why we will need a clamp. Alright. After that, what we will see, then we will start or lit a matchstick and will hold in the mouth of the test tube. And what we will see? We will see that this match, this will create a pop sound. Okay, now why this pop sound? This is because the evolution of the gas, and that gas is hydrogen. H2 stands for hydrogen. So we understand that with this experiment, in this experiment, hydrogen gas is being evolving. Now why this pop sound? This pop sound is because hydrogen gas is an inflammable. inflammable gas, and that's why it will burn out with a popping sound. Alright, that's why the reason of this pop sound when this little match has been hole in the near the mouth of the test tube. Okay, now when we are summing up, so these are the three changes which is happening, and this is proving what? This is proving that this is the entire experiment. This addition of zinc granule to the dilute hydrochloric acid is a chemical change. And why is this? Because after the addition of zinc to the dilute hydrochloric acid, as you can see this reaction, I have written out here. What has been created? The zinc chloride has been created with the evolution of hydrogen gas, and this marking of this upward marking of arrow denotes for the evolution of gas. This is a gas. Okay, so let's move to the next one. Now coming back to the next experiment, see here, when we are heating iron fillings with sulfur powder, what will happen? Okay, now how we are going to prove our point? What is going to happen? How will we see? To set up an experiment, we have to set up two sets. Okay, so for that reason we have created here two sets. Okay, so here there is a set number A. We will do the experiment and we'll see the observation. Alright, now here in the set 2 there will be another experiment set, and we'll see the observation and we will write it down. Alright, so let's see in the first set what we have done. We have taken a china clay dish. Okay, and we have poured some of the iron fillings and some sulfur powder, and we have mixed it together. Okay, and we have mixed it together and kept it inside the china clay bowl or dish. Then in the set B, okay, now we have mixed it together and kept it aside. Another in the set B, what we have done, we have taken the same mixture out here. We have mixed the iron fillings with the sulfur powder, and then we have placed this mixture in a china clay bowl in a tripod stand. This stand with 3 legs, that is called tripod stand. And then under this tripod we have placed a Bunsen burner that will provide the heat. Okay, so we have started the Bunsen burner and it started, and gradually we will see what? We will see that this mixture of iron filling and the sulfur powder, it will gradually, it will melt. Okay, so we will see what? Here the observation will remain no change. No change. Okay, now after here we will see what? We will see that the sulfur powder melts. It starts melting due to the application of heat. Then what happens? Gradually the color of the mixture turns dark green. Okay, so after then what we are doing to see whether there is any kind of change in their chemical property or not, so we are taking the help of a magnet, a horseshoe magnet. Okay, and we are tying it up with a rope and just holding it above the mixture. So when we are doing this equally for both the set A and set B. Now when we are doing this above the set A, what we will see that the iron fillings that are mixed with the sulfur powder, they get attracted to this magnet and it gets attracted. Say this black are the iron fillings, so they get attracted toward the iron magnet bar. Okay, So here we can see that there is no change. Iron filings retain their chemical property, right? Because iron gets attracted by the magnet, we all know that. Iron gets attracted by the magnet. Alright? So these are the observation from the set A. Now coming to the set B, what we are going to observe, that neither any of the mixture from this mixture is going to get attracted by the magnet. So what happened basically? Due to the, so what happens, we are going to write it down, observation. The mixture loses its attraction toward magnet, right? Now therefore how we can explain this phenomenon? This mixture which has been given with the heat, applied with the heat, and then we saw that the sulfur melts gradually and it becomes another mixture. So what happens, basically a new product has formed. And what is this new product? This is the iron sulfide. Okay, iron mixed with sulfur, when applied with the heat, it gave rise to another new product, that is the iron sulfide. And iron sulfide does not have that property to get attracted by the magnet. Okay, so this is how we understand that chemical property of iron sulfide is different than iron sulfide, that is the product, new product, different than the iron and sulfur. Therefore we can say that, what we can conclude from this observation, that this experiment is a chemical change. Okay. Similarly, now there are two substances I am going to talk about, that is rusting and charred sugar. What these two things are? These are the product, or we should say rust. Okay, rust, these two are the product of chemical change. What kind of chemical change? Let's talk about this. Okay, so what happens during rusting? The process is called rusting. Okay, in a rusting, what happens when an iron undergoes some of the, when it is exposed in the moisture, in presence of oxygen and water, that means it undergoes some change. What kind of change? It undergoes in presence of H2O, that is water and oxygen. Okay, so during rusting there should be presence of water and oxygen, that means moisture. So in short we can say moisture. So when we are leaving an iron product in the moisture for some long time, it will give rise to, what happens, an iron in presence of this moisture, it will produce hydrated or iron rust, that is basically hydrated iron oxide. And what this supposed to be? Hydrated means in the presence of water. And iron oxide, how this iron oxide form? Iron is the principal product, principal item, and in presence of oxygen it is forming iron oxide, and due to the presence of water we are calling them hydrated iron oxide. Now what was their property? They look reddish brown, okay, which is pretty different from the color of iron. Not attracted by magnet. Okay, so it loses its property. It loses its property of the parent product. Okay, that means our rust has a reddish brown color, and it is not further attracted by magnet because it has transformed into something else, a new product whose chemical property is entirely different from the iron. Okay, so and this total phenomena is called rusting. Now coming to the charred sugar. What is charred sugar? When we are taking some sugar. Now we know the basic nature of sugar. This is crystalline in nature and sweet in taste. So we are doing what? When a sugar is being heated. Let's heat them. When it is heated, initially first it melts. Sugar melts on heating. Then it caramelizes, and we know about the term caramelization, right? We know, we have eaten caramel. So gradually, what is the step after caramelization? During caramelization, we have seen that this crystalline sugar transforms into reddish color, greasy and glossy in nature. Then after that, if we keep on heating it further, it will gradually transfer into a product that is darkish, total black color in nature. So it will give rise to a product that is called charred sugar. Now what is the property of a charred sugar? This charred sugar has a property of, this is black in color, and does not taste sweet. Which are totally different property than a sugar, right? So basically what charred sugar is, this is carbon. Okay, so during the formation of charred sugar, carbon dioxide evolves along with other products. Okay, so these are some of the important chemical changes we needed to know for further accomplishment of our question answers. So see you in the next video with some question answers. So thank you for watching.